Okay, in this tutorial we're going to have a look at a modelling application of trig functions question. Okay, so this is very typical of the type of application question that you might see on a SAC or an exam for a trig function. Okay, so the depth of water in d metres, okay, at t hours after 6 am is modelled by the function d of t equals sine of pi t on 6 plus 2.5. Okay, and we're just going to go through this wet example. Okay, so you want to know what the period of the function is. So remember, we're a sine function. Okay, so the period equals 2 pi on n, where remember n is our coefficient of our variable inside our trig function, so it's pi on 6. So we can say that we've got 2 pi on 6, okay, which is going to give us 2 pi times 6 on pi, which is going to give us 12 hours in this case. So we've got a period of 12 hours. Okay, so the next part is what is the maximum minimum depth of the water. Okay, we can see here, okay, that our amplitude of our function, okay, is just 1. So we know we're cycling up and down 1, but we've also been translated 2.5 units vertically. So that means that from this 2.5 metres, we're going to go up by a metre, and we're also going to go down by a metre. Okay, so that means that we can see that our maximum depth is going to be 3.5 metres, while minimum depth is going to be 1.5 metres. Okay, now they want to give us what is our depth at 7 am. Okay, so here this is t hours after 6 am. So what we want to do here is say that we're going to let t equal 1, okay, not 7, because it's t hours after 6 am, so we need to be careful of that. So what we can say then is that d of 1 is equal to sine of pi on 6 plus 2.5, because we already let t equal 1, so it really more or less disappears. Okay, if we think about our exact values, if we think about our triangles here, okay, this is one of our triangles that we can use to help remember our values. This is pi on 6 up here. Okay, sine is opposite over hypotenuse. Okay, so 1 on 2. So sine of pi on 6 is 1/2 plus 2.5. So that's going to be 3 metres. Okay, remember it's a worded question. Okay, we've got units, so we need to make sure that we're including those units in there. Okay, so there's a couple more parts to this question. The next part they want us to sketch, so there should be one cycle of the graph of the function. Okay, so we're going to need some axes here. Okay, now remember this is our t hours and this is our depth. Now we don't need to think that we need to start at 6 because it was 6 am, okay, because it's t hours after 6 am. Okay, so we can simply just start where we at our vertical axis, our depth. So I'm going to move this down because we already worked out what our maximum and minimum values are. Okay, so we know we come up to a maximum of 3.5 metres and down to a minimum of, the scale's not very good probably, down to a value of 1.5 metres. Okay, and we've got a sine function here, so we know we're going to start our midpoint, going to come up. Okay, we also know that we've got a 12-hour period. Okay, 6 is also a good spot to put in there. Now it can be really handy just to give yourself some little guidelines here to help you draw it. Okay, which we can rub out afterwards. So I'm going to start at this midpoint. Okay, and come up. Okay, and down through that midpoint. And back up. Now I of course have the luxury of using whiteboard markers, so I can rub this out easy. That's why you should really always draw your graphs in whiteboard marker. In grey lead pencil. So I've got whiteboard marker. Okay, so and this point here, our end point, of course, is going to be 12 2.5. Okay, so that would be a graph of one cycle of our function. Now the next part, the council needs to know how long the water is more than 3.1 metres deep within a 12-hour period. Okay, so we're thinking about here, where's 3.1? Okay, it's going to be up here somewhere. So if we were to draw a line through there, okay, the council needs to know how long we're above this height, so we're really going to need to solve this and find these two values. Okay, when we found these two values, let's call this this one T1, and this one T2. Okay, once we found those two values, we can simply go T2 minus T1 to give us the difference in those time values, so they'll give us how long we're above there. Okay, so what we're doing is solving our equation equal to 3.1. Okay, if we know when it's equal to it, we know where it's going to be above. So let's say then that we've got sine of pi t on 6 equals 0.6. Okay, seeing this is 0.6, it's not one of our exact values. What we can do here is it's quite reasonable to realise that we're going to have to use our CAS technology here. Okay, so you simply put this in your calculator and solve it from this point. Now remember, you're going to get those values coming up in general form on your CAS calculator. So you just need to think about what that means. You're going to get your two answers here. One for the first quadrant of this graph, we're splitting it up. Okay, so we have our first quadrant and second quadrant. We know that because sine is positive. Okay, so we're going to be getting two general solutions. Okay, so we're going to be, for each of our solutions, we're going to be putting in or subbing in an n value of 0 when that spits out on your calculator. So when we do that, we find that we get two t values, which are 1.23 and t equals 4.77 hours. Okay, so we simply subtract one from the other, so we get a value of 3.54 hours. Okay, that we're above 3.1 metres. So if you weren't sure what I meant with the values being spit out by your calculator, check out some of my other videos on looking at general solutions of trig functions. Okay, and that will explain in a little bit more detail.